Hi, very good morning. Welcome to our ninth day of 21-day challenge. Hope you guys are ready for today's discussion. Before we start, do you have a good night's sleep? Ninth day of our 21-day challenge. Let's keep going. So first, we'll have some general discussion and then we'll move on to literature review, subject discussion. So one of the most common things which we often face, almost on not daily basis but moment to moment basis, given the situations we are in, given the challenges we face, that's frustration. So what's this frustration? Why do we find or feel this frustration? And if at all there are any tools, how to overcome them? Right. So frustration is an emotional feeling which develops whenever some important goal cannot be realized or when some strong desire is thwarted. All of us must necessarily suffer some frustration by the very fact of being human and therefore imperfect, incomplete, unfinished. As we grow older, we should learn that all desires cannot be satisfied immediately. We also learn that our doing can never be as good as our intentions. We also learn to accept the fact that perfection is not necessary nor required, and that approximations are good enough for all practical purposes. I mean, this is based on practical experience, or this is based on one's personal experience. We can connect with this particular literature. So, frustration is something which happens within us when we set goals and with pure intentions. But when it comes to practicality, we find it very tough or challenging to accomplish that. So, that obviously leads to frustration. We learn to tolerate a certain amount of frustration without becoming upset about it. It's only when a frustrating experience brings excessive emotional feelings of deep dissatisfaction and futility that it becomes a symptom of failure. Chronic frustration usually means that the goals we have set for ourselves are unrealistic or the image we have of ourselves is inadequate or both. So that's the reason why, if you observe the compliance report, if you start setting next week targets, if you gradually try to reach your targets in accordance to what you have set in your compliance report and modify them accordingly, you'll overcome this feeling of frustration to a greater extent. But having said that, there can be still numerous reasons for getting frustrated. But if we probe and if we ask ourselves why, is it because we are unable to accomplish our unrealistic goals, or is it because we have inadequate self image, or is it both? So I'm sure we'll find answers to these questions. And who else is best to answer these questions than ourselves for our own sake? So this is something which I wanted to highlight in this particular general discussion. So, very well said, and it cannot be more true. Frustration is an emotional feeling which develops when some important goal cannot be realized or when some strong desire is thwarted. And as you can see, as we grow older, we should learn that all desires cannot be satisfied immediately. You know what? That's one of the main problems with the current generation. We want things to be done instantaneously, and when things are not done instantaneously, just like that, then we obviously start developing frustration. But there are certain aspects in life which cannot be done or cannot be achieved instantaneously. They take time. Relations, for example, achieving your personal professional goals, for example, some things take time. Not everything is like a WhatsApp message being delivered instantaneously, isn't it? So it's only when a frustrating experience, so according to author, some extent or some amount of frustration is acceptable as we experience on daily basis, or else we would have to end our life at one point. but only when it grows to such an extent that it brings a deep sense of a dissatisfaction and futility, it is considered as a symptom of failure. So, in fact, frustration is a deep frustration or a heavy frustration or a chronic frustration can be considered as a symptom of failure. And finally, we'll conclude with this. Chronic frustration usually means we have either unrealistic goals or inadequate self image or both. So, who else is going to answer this question? Uh, we should answer it for ourselves, as I mentioned prior, right? So, one practical tip which I can give you out of my experience to overcome frustration is set realistic goals. Easy said than done, and not at all. Just take out your compliance report. You have these next week targets. Set goals in such a way or to such an extent that you would accomplish them without much negativity. In the sense, we've discussed about minimum criteria principle several months ago. So this is based on the fact that we can overcome or avoid frustration by setting certain minimum criteria in a day or in a week related to our preparation. So minimum criteria, like if you note down on a piece of paper or complaints report that you wish to practice a minimum of 100 MCQs in that particular day or particular week, depending upon your time convenience. And once you accomplish it, you'll have that sense of satisfaction. And of course, you're thwarting that feeling of frustration gradually, right? Okay, yeah, now let's move on to our academic part. So, in today's academic part, we'll have a review of biochemistry and its relevance to various other specialities in medical sciences and how it's going to change human life forever. The reference is world of microbiology and immunology. These are certain things which we usually neglect or miss out while going through preparation, but to give more meaning to our preparation, to just realize the fact that subject is not just about practicing memorizing certain MCQs, it's a way more than that. I've incorporated this particular aspect here. So let's review and enjoy what the actual subject is all about and how or to what extent it's going to have an impact on human life. Yeah, I reckon now it's readable. Yeah, so biochemistry, the moment we hear the term biochemistry, jitters are a common, obvious feeling which we experience thanks to our UG curriculum or how we approach biochemistry in our undergraduation. So, whatever the reason might be, let's look into this literature from the reference world of microbiology and immunology. So, biochemistry seeks to describe the structure, organization, and functions of living matter in molecular terms. Essentially, two factors have contributed to the excitement in the field today and have enhanced the impact of research and advances in biochemistry on other life sciences. First, it is now generally accepted that the physical elements of living matter obey the same fundamental laws that govern all matter, both living and non living. We're talking about principles of physics and chemistry, which also apply to living beings. Therefore, the full potential of modern chemical and physical theory can be brought in to solve certain biologic problems. Secondly, incredibly powerful research techniques, notably those developing from the fields of biophysics and molecular biology, are permitting scientists to ask questions about the basic process of life that could not have been imagined even a few years ago. And also, if you observe, for the past several years, Nobel Prize winners are increasingly from the fields of physiology, medicine. There, some of them are even biochemists. Okay, let's continue. Biochemistry now lies at the heart of a revolution in the biological sciences, and it is nowhere better illustrated than in the remarkable number of Nobel Prizes in chemistry or medicine and physiology that have been won by biochemists in recent years. A typical example is the award of 1988 Nobel Prize for Medicine and Physiology to Gertrude Elion and George Hitchings of United States, and Sir James Black of Great Britain for their leadership in inventing new drugs. Alien and Hitchings developed chemical analogues of nucleic acids and vitamins, which are now being used to treat leukemia, bacterial infections, malaria, gout, herpes virus infections, and AIDS. Black developed beta blockers that are now used to reduce the risk of heart attack and to treat diseases such as asthma. These drugs, remember, were designed and not discovered through random organic synthesis, thanks to our understanding of the basic elements or the molecular basis of living creatures and developments in knowledge within certain areas of certain key areas of biochemistry, such as protein structure and function, nucleic acid synthesis, enzyme mechanisms, receptors, and metabolic control, vitamins and coenzymes all contributed to enable such progress to be made. So it's not a separate entity. In fact, this biochemistry has impact on other life sciences. We've just seen how we're able to treat various infections or various conditions thanks to the formation or designing of certain chemical structures. Remember, these were not discovered. Rather, based on the understanding of biochemical principles, they were designed to treat specific conditions, which is very interesting. Two more recent Nobel Prizes give further evidence for the breadth of impact of biochemistry. In 1997, the chemistry prize was shared by three scientists, the American Paul Boyer, British J. Walker, for the discovery of a rotary engine that generates the energy carrying compound ATP, and Danish J. Scow for his studies of pump that drives sodium and potassium across membranes. In the same year, the prize in medicine and physiology went to Stanley Prusiner for his studies on prions, the agent thought to be responsible for mad cow disease and several similar human conditions. Biochemistry draws on its major themes from many disciplines. For example, from organic chemistry, which describes the properties of biomolecules, from biophysics, which applies the techniques of physics to study the structure of biomolecules, from medical research, which increasingly seeks to understand disease states in molecular terms, and also from nutrition, microbiology, physiology, cell biology, and genetics. Biochemistry draws strength from all these disciplines, but is also a distinct discipline with its own identity. It is distinctive in its emphasis on the structures and relations of biomolecules, particularly enzymes and biological catalysis, also on elucidation of metabolic pathways, which we are most dreaded of, and the control and on the principle that life processes can, at least on the physical level, be understood through laws of chemistry. It has its origins as a distinct field of study in early 19th century with the pioneering work of Friedrich Euler. Prior to Euler's time, it was believed that the substance of living matter, this is very interesting because he changed the attitudes. How? Prior to Euler's time, it was believed that the substance of living matter was somehow quantitatively different from that of non living matter and did not behave according to known laws of physics and chemistry. In 1828, Euler showed that urea, a substance of biological origin excreted by humans and many animals as a product of nitrogen metabolism, could be synthesized in laboratory from the inorganic compound ammonium cyanide. As Euler phrased it in a letter to a colleague, I must tell you that I can prepare urea without requiring a kidney or an animal, either man or dog. This was a shocking statement at that time, for it breached the presumed barrier between the living and non living. Later in 1897, two German brothers, Eduard and Hans Buchner, found that extracts from broken and thoroughly dead cells from yeast could nevertheless carry out the entire process of fermentation of sugar into alcohol. This discovery opened the door to analysis of biochemical reactions and processes in vitro, which in Latin means in glass, meaning in the test tube rather than in vivo, that is, in living matter. And you know that both things are governed by same principles, that is, living and non living. In succeeding decades, Many other metabolic reactions and reaction pathways were reproduced in vitro. So, if you want to blame someone for all the metabolic pathways or cycles, here you have. So, in succeeding decades, many other metabolic reactions and reaction pathways were reproduced in vitro, allowing identification of reactants and products and of enzymes or biologic catalysts that promoted each biochemical reaction. We're about to conclude. Until 1926, the structure of enzymes were thought to be far too complex to be described in chemical terms. But in 1926, Sumner showed that protein urease, an enzyme from jack beans, could be crystallized like other organic compounds. Although proteins have large and complex structures, they are also organic compounds and their physical structures can be determined by chemical methods. So you can actually study the structure. Today, the study of biochemistry can be broadly divided into three principal areas. Number one, the structural chemistry of the components of living matter in relationships of biological function to chemical structure, structure of DNA, structure of RNA. And number two, metabolism, the totality of chemical reactions that occur in living matter. And number three, the chemistry of processes and substances that store and transmit biological information. So this third area falls under molecular genetics, a field that seeks to understand heredity and expression of genetic information in molecular terms. Biochemistry is having a profound influence in the field of medicine. The molecular mechanisms of many diseases, such as sickle cell anemia, numerous errors of metabolism have been elucidated. We talk about valine, glutamine, replacement of positions. This is possible only because we are able to study at a molecular level. Assays of enzyme activity are today indispensable in clinical diagnosis. The best example is in case of liver disease, you try to assess liver enzymes. So, to cite just one example, liver disease is now routinely diagnosed and monitored by measurements of blood levels of enzymes called transaminases and of a hemoglobin breakdown product called bilirubin. How indispensable are these to establish or to guide a physician in treating his or her patient? So, DNA probes are coming into play in diagnosis of bilirubin, in diagnosis of genetic disorders, infectious diseases, including cancers. Genetically engineered strains of bacteria containing a recombinant DNA are producing valuable proteins such as insulin and growth hormone. Furthermore, biochemistry is a basis for rational design of new drugs. We have seen a few examples prior how the Nobel Prize winning scientists or biochemists actually devised or designed certain drugs like beta blockers. Also, the rapid development of powerful biochemical concepts and techniques in recent years has enabled investigators to tackle some of the most challenging and fundamental problems in medicine and physiology. In case of, for example, embryology, the mechanisms by which the fertilized embryo gives rise to cells as different as muscle, brain, liver are being intensely investigated. Also, in anatomy, the question of how cells find each other in order to form a complex organ, such as liver or a brain, are being tackled in biochemical terms. The impact of biochemistry is being felt in many areas of human life through this kind of research, and the discoveries are fueling the growth of life sciences as a whole. So, if at all, any biochemist is going through this particular live session, he or she would be on cloud nine without any doubt. So, biochemistry is not monotonous, biochemistry is not boring, biochemistry is not just about blindly mugging up certain cycles. It has a lot more than that, as we have just seen, as we have just appreciated the scope of biochemistry and to what extent it is impacting other life sciences and how various other subjects are essential to learn biochemistry as such. And the most interesting thing which I have found out in this entire review is that the laws which govern the non living, that is, laws of physics and chemistry, are the same laws which are governing even the living. Because if you break down the composition, the basic things remain the same. What we find in soil, and what we find in ourselves. The basic elements, the basic constituents are the same. So it's obvious that the laws governing the physics or chemistry or the non-living are similar or same to that of laws governing a living. Right. So this is one of the beautiful reviews which I've come across, and I wanted to share with you all. And before I conclude, so any subject for that matter, when you try to visualize it with a broader perspective, it's going to be fun and interesting. And as I said, any subject, if not viewed through a proper perspective, will be very boring, very monotonous, and we feel like giving up. So the same applies even to biochemistry, or for that matter, any other subject. So to summarize all that we have discussed so far, initially we have seen how or why we experience frustration, and one or a couple of tips on how to overcome the same. The only thing I wanted to keep in mind is, or the take home message is, when you're setting goals, make sure that they are practical or practically feasible enough, and also they are realistic, right? So always keep that in mind. And of course, you can get back through mail for guidance in that regard. We have an exclusive column for next week targets in a compliance report, which we can make maximum use of to accomplish your minimum criteria tasks. And secondly, we've seen biochemistry and its scope. So much of interesting information. You can go through it again in your free time and see how it is transforming life. And not just biochemistry for that matter, you take any sciences, it's there to transform human life. The pace might vary, but that's what eventually happens, right? So, with these remarks, let's conclude our live session, day 9, 21-day challenge, 5 a.m. club. And as I said, if a biochemist were watching this live session, he or she would be on cloud 9 for the obvious reasons. Okay, right. So, you have any further queries or you need any further clarification, always feel free to get back through mail at proudtobedentist@gmail.com. Let's keep this momentum going, and I really appreciate you all for actively participating in this 5 a.m. session. It's no easy task, because to wake up early, we need to sleep early, and to sleep early, we need to resist lots and lots of temptations, lots and lots of distractions. Just keep this momentum going and enjoy the benefits of 5 a.m. club. Love you all. Have a fantastic day ahead.